Hello class, Dr. Mike here with a little bit of Linux for you. So we're going to start talking about mounting file systems. Now we may have already did this, actually I did do this in a previous video, but we're going to go over some of the deeper aspects of mounting file systems here. So first off, as we've seen before, you actually take the file system, like our dev SDC one, let's say. We created a partition, and we mount that to a directory, let's say data. So pretty straightforward. Couple things to note here. There's some best practices to look at. Red Hat, CentOS, look at different development guides, system administration guides for best practices. You have a lot of options when mounting. We'll look at those in a second. Straightforward though, our main command is the mount command. Mount command can tell us what's currently mounted and also is used to mount something. The df command can show us what's mounted, and of course we know what was seen before. We use that for space usage and to see how full our file systems are. So mounting is pretty straightforward. It's mount, and we'll do this here in a demo here. It's device to our mount point. And this is a directory. Now, if that directory is existing already and it has files in it, then will not be overwritten. What happens is this overtakes it. So anything that's written to this gets written to this mount point. And then when you unmount it, the files that are here already will still be there. However, it's good practice not to use a existing mount directory that's used for regular file use. You want to have a special area to mount things. MNT, you might see that by default, and we'll look in our system here. Or you might see /media also. Media, a lot of times /media is used for like USB devices when they're plugged in. To unmount, it's Umount. Yeah, there's no N inside there. It's not a misspelling. So pretty straightforward. Umount, you can put the device or the directory name. You will get a failure if its files are open, something's running, or someone's logged in, or someone's sitting in that directory. So, and it will come back, it will tell you that if it's busy. You can also use the fuser command to check to see what's being used, see what processes are running, what files are open, and then hopefully resolve those either with the person in person over some form of communication, or just you could, as a root, kill their system, kill their script, kill their access. But be careful doing that. You could actually leave open files with some corruption on the disk. So, but you can fuser-k basically stop all processes on that mount point, or use the fuser-kill, send the kill signal to that. And after that, you can unmount it. So in an emergency situation, you can't get a hold of a certain user who's running a process, and you need to unmount that. You can do this process as system administrator. So now we'll go back. We'll demo the mounting and unmounting manually. We're also going to look at the etcfs tab. So we have a data directory, let's say again, and we want to mount that every time the system boots. Well, if you just mount something once manually and you reboot, it will not be mounted. So you have to add an entry in the etcfs tab. Definitely a good idea to have a backup of this this file somewhere, maybe in /root, just in case it gets in a bad state. So again, you must be root for all to do this. No surprise there. So we have a set of fields, pretty straightforward. The first field, and we'll see this in the demo here, is our device name. Now the device could be an actual device name like dev sda1. We can have a logical volume identifier. A UUID, which is basically a unique identifier, which you can get. That could be good, or a label could be good. If you have a situation where a certain device has to be mounted, a certain, let's say, drive and partition has to be mounted to a certain directory, In my experience, it's only happened once, but I've had it where we switched SCSI controllers, SATA controller, and it remapped what these mounted to. So like SDA1 used to go to a certain partition. It messed some stuff around. Again, most of the time you really don't need it, but just think of something to look at it for as a scenario you could maybe encounter, especially with logical volume mounts, LUNs, or SATA, fiber attached storage. Some things to consider there. Again, look at the best practices for that device and that server. So again, UUID, the partition names can change if new devices are added. Again, most times this is pretty much a low risk, but something to consider. But you can use a block ID to view what this is, and use that to mount that to that mount point. Labels are just that. Labels, almost like a label affixed to the old floppy disk days. So you knew what it was used for. You can actually assign labels with our E2 label command. And then that allows you to go ahead and mount by label itself. So other mount point options. The mount command itself has options. A lot of options here we can use for it. Let's look at them. Here we go. Probably the most common, maybe read-only. Maybe I actually have an external hard drive of maybe test scripts, and I want to mount that for my developers to view, but I don't want them to be able to write to that partition at all, that mount point. So you can mount it as read-only. Asynchronous, real-time, auto, automatically mount, a lot of device files. There's a lot of, this is only a partial list. So again, you have to think about the scenario of what is being accessed, the data, and what rules you have around it. So in case, let's take a quick look here. All right, so again, let's look at fdisk-l, and you see I have my dev SDC1 here, really small, but I want to use that to mount data to. So again, the mount command is mount device to directory. Let's first make the directory exists. So if I ls-l, you can see there's no data here. Now there is a mount, MNT, and there's also media. You could actually create a very small partition and use that with sort of like an isolated mount point. Again, the problem is here, and what we're trying to approach is if I mount something to /mount here, and it stays mounted, maybe an external hard drive, and I have a process writing files to it, and for some reason it unmounts, this process will keep writing files, and MNT is part of my root file system right now, and so I can fill up my root file system. Something to consider is a possible risk. There's a trick we can do. I'll do it here. So first off, let's make directory data, and I will see it's here. Now a trick I've always used before in the past is to chmod this. I'll look at it again. So I zero it out. It's all zeroed out. I chmod 000 the data directory. So now no one can write to it at all. It's totally unwritable. Now, but if I mount my dev SDC1 to data, if we look at this, you'll see it's back to its regular state. So the mount command will reread the umask, and so reapply it upon mounting. If I unmount it, which will look at that command, which is umount, in this case data, it's back to its state of being unwritable. So again, our command is our mount command. You can do -o and have a lot of options, make it read only and so on. But in this case, mount dev SDC1 to data. If I do df, df-h, let's say, you can see It's very small, it's only 200 megabytes. This is a test demo here, but it's mounted and it's 6% full. The mount command with nothing passed to it will give you a full list of everything, including how they're written out, how they're mounted, their options. So example, proc, for example, which is actually in a real file system. Proc is part of the basically our kernel and memory, but it is mounted like a file system. You can see read right here. So if I mount dev-SCC1, you can see here in the bottom, it's dev-SCC1, it's ext4, it's readable time, SCC labeling for C Linux, attributes. I got to look some of these up myself, so at least you can see these. So let's say if you mounted something read-only, you want to verify it, you can look at mount and it'll say RO for read-only. So let's look at that next file, which is our cat etcfs tab. So etcfs tab, this is what you use to mount upon boot. So if I wanted to create an entry for this data here, first I would back this up. Let's copy etcfs tab to here. You can see I'm in my root home directory and root. There's a copy of it here. That's fs tab. etcfs tab. All right, so we can see here we have our device, in this case dev mapper logical volume root from our logical volume lesson. That's how we call those. It's mounted to slash. It's ext4. It's using all defaults. And these last two fields, 1, 1. So we're looking at is the FSCK field, whether it's be FSCK'd or not, and sort of the order. The idea being if something happens, this is a server, it's running fine, and power goes out, and the power supply or fails, it crashes. When it comes back up, FSCK, which is our file system check, we'll look at this and say 1 for yes, and what order to do it in. In this case, go ahead and do logical volume for root. Basically do almost like a check disk. Windows, same as in Windows is check disk, it's FSCK. And do that first, and then yes, do this one, this is our boot, and do it second. The swap, of course, is 0, 0. Don't do it at all. So let's go ahead and add a file here. So we're going to do dev sdc1. You can do the spacing how you see fit. There's no rules, loose rules here, but we want to mount it to data. It's an ext4. We'll take defaults, and then we're going to go and do a 0, 0 on that. So it's our device, our mount point. And if we wanted to, we can make this a little more presentable here. Which you might see a little easier to read. And let's put the 0, 0 out there. So you can see here, yes, I've set up an entry for dev SDC. Upon boot, it will /data mount to /data, and it'll do it as ext4 with all the defaults and with no need for FSCK. If I wanted to, I could, of course, make this. If this is like a database, I want to make sure that all the files are in good working order. So in case, that's our save that, and we're good to go. And that is our mounting and unmounting of file systems.